Okay, hello and welcome everyone. In this video, I'm gonna continue on through this collection of intermediate micro consumer theory maximization problems. So I'm gonna do these. I'll go through a couple that I'm gonna intend to do in this video, and hopefully I'll get through them all if things go as planned. So Bob has preferences given by these, right? Otherwise they'll be in the next video, right? So I'll get through them all eventually. So these are perfect complements preferences: 2x, 3y. Bob's income is 8. Price of good x is 2. Price of good y is 1. What's Bob's optimal choice? Are these complements or preference? Or substitutes? Complements, preferences, or complements, right? Some support for how you know. Well, you'd want to talk about how price and quantity. Sorry, you'd want to talk about how price of good x affects demand for good y and vice versa, but you'd probably just reference your demands. Same thing here. It's a slightly different utility function. All right, so Bob has quasi-log linear utility. Bob has income. What's the marginal rate of substitution? Solve for Bob's optimal bundle. Bob's income falls. What happens to the optimal bundle? Question 23 is a lot like that one, so I won't spend as great detail on 23 because it's just putting a 4 here. And has this utility function. F is the quantity of food consumes per week, and H is the quantity of housing per week. Suppose the price of food is 10, price of housing is 5, and income, show the optimum. All right. Yeah, I'll go up to like 27 or something. Yeah, that looks good. So Bob has these preferences. These are kind of cool, actually. XY, which is Cobb-Douglas, but then this is plus X, which is substitutes. Bob's income is 22. Price of good X is 2. Price of good Y is 2. What are Bob's demands? Bob has these preferences. These are slightly different prices, right? What are Bob's demands? Ann has these preferences. Quasi-linear. Ann's income is 14. Price of good X is 2. Price of good Y is 3. What are Ann's demands? All right, and then we'll stop before the Cobb-Douglas. That'll go into the next video. All right, so I'm going to put this here so I remind myself not to do that one. Good. All right, so we are picking up with this one right here. Bob has these preferences. Bob's income is 8. Price of good X is 2. Price of good Y is 1. So with perfect complements, you replace the comma with an equal sign to get the line through the origin that connects the corners. This is going to be 2x plus 2x is equal to 3y, or y is equal to 2/3 x. I'm going to substitute that into the budget constraint. So I'm going to replace y with 2/3 x. 2x plus 2/3 x, or 6/3 x plus 2/3 x to get a common denominator of 3 is equal to 8. 8/3 x is 8, or x is equal to 3. If x is 3, then y is 2. So that's how I got Bob's optimal choices here. The good substitutes are complements. I said complements, and I reminded us of a perfect complements preference structure, giving us demands that are going to be income typically times like some constant, and then some constants on these. But if I don't have constants there, it's just demand for x is the demand for y. It's symmetric. M over px plus py. If you change the price of x or the price of good y, the demand for both moves in the opposite direction. All right, so Bob's income is 8. These are the new preferences. Bob's income is 8. Price of good x is 1. Price of good y is 1. I say TC, this is like a tangency condition. It's the optimality condition. It's the line that's going to go through the corners. So let's replace this with an equal sign. 3x is equal to 5y, or y is equal to 3/5 x. Drop that into the budget constraint and then solve. So let's see, I replace y with 3/5 x, right, is equal to 8. X plus 3/5 x, or 5/5 x plus 3/5 x is equal to 8x over 5. X is equal to 5. Y is equal to 3. Same work as the same work as this, but different numbers. The substitutes are complements. They're complements, right? For the same reason as before. All right, Bob's quasi-log linear utility function, q1 plus 2 natural log of 2. Bob has income of 100, face prices that are equal at 20. What's the MRS? Okay, so the marginal utility of good 1 is just 1 because that's the coefficient on q. The marginal utility of good 2 is going to be 2 times 1 over q over 2. 2 times 1 over q2. All right, so I'm going to have 1 over 2 over q2 is going to be q2 over 2 is Bob's MRS. What do we want to do next? Oh, that was this right here. So mu1 is 1, mu2 is 2. I actually wrote this out more carefully. That's this. Price ratio is going to be 1. 20 over 20 is 1, so I'm going to set q2 over 2 equal to 1. Q2 is equal to 2. Remember, with quasi-linear utility, there's one good that the consumer's just really focused on, and here it's good 2. So they want 2 units of good 2. Solve for Bob's optimal bundle. Well, Bob has 100 units available, so Bob's going to buy 2 units of good 2, which is going to cost $40 because the price of good 2 is 20. Sorry, the price of good 2 is 20. And now Bob's going to have $60 with which to buy good 1. So Bob's optimal bundle is going to be 2 units of good 2, 3 units of good 1. Now suppose Bob's income falls to 20. What happens to Bob's optimal bundle? Well, the key thing to remember is that Bob really wants 2 units of good 2. If Bob can't attain 2 units of good 2, Bob's just going to buy whatever Bob can afford. So Bob's going to buy 20 divided by the price of good 2, which is 20. So Bob's going to buy 1 unit of good 2. Bob's not going to buy any of good 1. So it's a corner solution, and the marginal rate of substitution is not equal to the marginal rate of transformation. Marginal rate of substitution is not equal to the price ratio. So what's happening? With quasi-linear, the consumer focuses the consumer on a specific amount of one good. They won't buy, in this case, good 1 until good 2 hits a level of 2. They won't get any more of good 2 either beyond this. So if Q2 over 2 is less than 1, so this is Q2 over 2. This is the price ratio, which is 1. If Q2 is less than 2, which occurs when income is less than P2, Bob's going to put it all towards good 2. So what's happening is when the income is less than the price, Bob's just going to put everything towards good 2. Why? Well, this is comparing the MRS to the price ratio. MRS to the price ratio. So if Q2 is something smaller than 2, then the budget constraint is going to be steeper. That's like our alley solution. That's going to have a tendency towards buying all of our Y good. In this case, that's good 2, right? So that's my comment here. When the Q2 divided by 2 is less than 1, so MRS is less than the price ratio since Q2 is smaller than 2 because Bob can't afford both units because his income's too small. So the MRS is less than the price ratio. The consumer wants more of good 2 and less of good 1. It's the same logic as our alley solution with perfect subs. So we draw the picture, steeper budget constraints, flatter indifference curves, and indicates the consumer wants more of the Y good, in this case good 2. It's not quite like a corner solution like you get with Ali and Alex in our perfect substitutes cases, but you can borrow that logic to justify why Bob's going to spend, why if Bob can't afford 2 units of good 2, why it's the case that Bob's going to spend the little money that Bob does have on good 2 and not on good 1. It's that logic right there, which I think is really cool. All right, so part B, okay, so income fall, we did this. Okay, here's the next one. Suppose Bob has quasi-log linear utility. Now the coefficient is 4 and the prices are the same, but they're are equal to each other, but they're 10. Income is 80. What happens? Well, here's the MRS for the same reason above. It's going to want to consume 4 units of good 2, exhaust the budget, and so he'll buy, let's see, 4 units of good 2 and 4 units of good 1. It's going to do it. Suppose Bob income falls to $10. What happens to Bob's optimal bundle? Again, Bob can't afford 4 units of good 2, so Bob's going to buy 1 unit of good 2 and no good 1. And this is a corner solution, same logic as above. All right, so here's Ann. Ann has Cobb-Douglas utility. This is the quantity of food Ann consumes per week. It's quantity of housing. Suppose the price of food is 10, price of housing is 5, Ann has income of 150 per week. Calculate Ann's MRS as a function of F and Y. Well, the MRS, so take the partial with respect to F. That's going to be 20F, reduce the power by 1. That's just going to be 20FH, right? 20FH. The marginal utility with respect to Y is just going to be 10F squared. Right, this is a constant. It's like a constant coefficient on H. We do this division. The marginal rate of substitution is going to be 2H over F. Good. Set that equal to the price ratio, which is going to be 10 over 5, which is 2. All right. And then you'd find whatever you could substitute. That's not how I do it in this problem. So the way that I did it in the problem is I said, let's write out Ann's constrained optimization problem, this right here. Solve for Ann's optimal consumption bundle of food and housing. Now I'm demonstrating a different type of solution in the solution. You probably want to just do this with a standard Lagrangian approach, or like I was starting off saying. What I've done here is I've said, well, let's take the budget constraint. Let's solve the budget constraint for F. Here's the budget constraint, solve it for F. So it's going to be 150 minus 5H divided by 10, or 15 divided by 1/2 H. Substitute that into the optimization. What I've done is I've gone from a constrained optimization to an unconstrained optimization problem by substituting in the constraint before the maximization. Then I take the derivative with respect to H because it's a function of one variable. So the first order condition is just this line right here. Solves for my optimal value of H. Plug back into the budget constraint to get my optimal F, which is 10. If I do this on your own, like the standard way, you'll verify you get the same thing. The other thing that's interesting with this question is show at the optimum and consumes a bundle along the budget constraint where MRS is equal to MRT. That's got to happen. We have an interior solution. We know the optimal, the tangency condition holds. So let's just evaluate the MRS at the optimal and see if it equals the MRT. The MRT is going to be 10 divided by 5, which is 2. So is our MRS equal to 2 at the optimum? What was the optimal bundle? 10 and 10. So what I'm going to do is I'm going to take my MRS, which is 2h over f, and I'm going to evaluate at 10, 10. So I'm going to plug in 2 times 10 over 10. Sure enough, that's 2. So that verifies that it holds at the optimal. Bob has preferences described by xy plus x. Bob's income is 22. Price of good x is 2. Price of good y is 2. What are Bob's demands? So the MRS is going to be y plus 1 over x. Why? Because the marginal utility of y, marginal utility of y is just going to be x. Marginal utility of x is going to be y plus 1. Marginal utility of x is y plus 1 divided by marginal utility of y, which is just x. So that's my MRS. Tangency is going to be 1 over 1. Price ratio is 2 over 2, which is just 1. Sorry, not 1 over 1. 2 over 2, which is 1. Solving, this is my tangency condition right here. Y is equal to x minus 1, which is really easy, straightforward to plug into the budget constraint. Budget constraint was 22 is equal to 2x plus 2y. Let's substitute 22 is equal to 2x plus 2 times the quantity x minus 1 from this right here, replacing for y. Solving, I'll have 22 is equal to 4x minus 2, or 20 is equal to 4x. 24 is equal to 4x, or x is equal to 6, y is equal to 5. Then let's do the same problem again, but now with income of 27. Prices are 3 and 3. We are going to have the same marginal rate of substitution because it's the same preference shape. Tangency condition is the same. So the thing that we're substituting into the budget constraint is the same. And then solving, we get x is equal to 5, y is equal to 4. And then I think I said we were going to stop at 27. I think I said I was going to stop there. So I will stop. I'll do question number 27 in the next video. I hope you enjoyed. I'll leave the comments open so you can ask me questions or send via email. So I'll see you next time.